So here's UIKit and more, a deeper look into iOS development.
Okay, well, so let's talk about how iOS works. If you guys are familiar with MVC, it's MVC. You have view controllers and your views, and we'll touch models in a second. But first, we're going to start with the delegate design pattern, where your UI view controller is going to communicate with your view. This is, for iOS, this is basically what you're going to use this for. We're going to look at it a little broader, because you can use this between any two objects, and you can touch anything you want.
Okay, so delegate is a design pattern that you're probably not used to if you live in Java land. Pretty much, you have two objects. Well, you have an object that provides a service, but it needs more information about the service. So it provides a delegate, which is a contract that another object promises to adhere to. In Objective-C, these are called protocols. Now, and it has the object that provides the service has a property within itself, normally called delegate or data source, depending on what kind of information it needs, or what kind of information it needs to give and respond with. And another object implements the protocol, the delegate protocol, and assigns itself to the service object. And then the service object can then ask, hey, give me your information? Cool. Okay, here's some information. Awesome. It's a nice, easy way to provide communication between two or more objects. And a lot of times it's used for views in iOS. You have a UI view that needs information about how to view itself, so it asks normally the view controller, but really it could be any object that it is assigned its delegate for that information. So, if you're the view controller, you set yourself as the delegate most of the time, because you probably implement all the methods, and you probably have the data. That's just the nature of the view controller. And if you're the UI view, you assume someone is your delegate. Most of the time, in Objective-C, it's okay to pass messages to nil, so it won't be bad if there's no delegate. Most of the time, there is a default property if there is no actual implementation of the method within the delegate object. So using delegates, you're going to implement the protocol, delegate protocol, like you implement protocols in Objective-C, and then set yourself as the delegate for the view. And you're not going to do it to UI view because UI view is a class, and that's not what you do. You do it to instances. If you are a delegate yourself, and you're not going to know how the UI view does it, but if you want to make your own, if you want to use the delegate pattern yourself, you would have a delegate property, which is of type ID, so it's any object that implements the delegate protocol. And you would define the delegate protocol yourself in the header file. And then normally you would do a check. If my delegate responds to the method that I want to call on it. And you normally have a default value, just in case something happens. So UITableView uses this a lot, with both a delegate and a data source. And would you like to go into this?
Yeah. So obviously, a data source is going to be where you're going to get data to populate your table view, and a delegate is going to be more methods that you can use to customize your table view. So, believe it or not, a delegate actually doesn't have any required methods. This is just for UITableView. It doesn't actually have any required methods that you need to implement in order to be a delegate. But if you want to call on any of these methods, you do have to set yourself as a delegate. So you can actually go to the declaration for the protocol, for the delegate protocol, by when you in the square brackets. I think, so in your header file, you'll put this after your subclass, and this is where you're defining your protocols. If you actually command click on one of these, it'll take you to something that looks like this. This is the header file for the delegate, and you can't really see it very well, but this is actually the protocol for a UITableView delegate. So these are methods that you can implement yourself if you want to. There aren't actually any required ones, but if you want to do stuff like this, you can look into it yourself. But what we're going to touch on is the actual required methods for being a data source. So obviously your table view needs data, so here's how you get data to your table view. First you have table view number of rows and selection. It's a required method by the protocol. Basically, how much data is going to be in your table. You'll implement this method and you'll return an integer saying, here's how many rows I have in my table. And then table view, still for table index path. So at the index of row that you want to put data in, that's where you return the data that's going in that row. And we'll touch on that here shortly.
I want to point out something that's normally used in the delegate pattern. Notice how it passes in the table view that it wants that this method is being called by. That's normal. That's the normal way delegates are called. They say who's calling them. So your one view controller could be the controller for multiple different table views. So it passes in which table view it's a controller for, and you can give different return values based on which one. It's not always the case that you end up actually being a delegate for more than one object, so most of the time it ends up being ignored, but you do have the option of having one method to rule them all, so to speak. An index path is just a nice, because it's called self-heroic index path. An index path is an NSObject way of keeping track of multiple different indexes of an array, or a whole bunch of arrays. Let's say you have an n-dimensional array. That means you have you need n different indexes in order to get any specific index. UITableView uses that to its advantage so that you can have sections of rows and individual rows within the section. So there are nice UIKit methods for getting the index path, for creating an index path for a section and for an index in the section. And it's actually not complicated, but approaching it from just new eyes, it can be a little strange.
So this is just the protocol declaration. You'll notice there's the @required, that's defining the required methods, and then the @optional, which defines the optional methods. One that I find very helpful actually is, where is it? Can't even see this. Well, you can actually set at an index path the cell height, which sometimes can be difficult, but that's actually the only ever optional method I've ever really implemented in TableView. But this is a little better here. So this is actually how you'd implement it in your view controller if you're using table views. So you have, basically you're going to have an array with all your data, and we can talk about populating that array later. But you return your count for how many rows you're going to have. And then in this method here, you get an instance of the cell. You create, in Storyboard, you create prototype cells, and you can give them a reuse identifier. So, or you can actually just do this by defining your own classes and subclassing UITableView cell. But, so you do that, and then you get all your attributes of your cell. You can set labels, images in your cell, and everything. So just like setting properties on any NS object, you do that here, and then you return the cell. So, we also have UICollection Views. Do you want to do this one?
Sure. So a table view is a nice way of getting a list of things with sections of the list. But for the longest time, there was no way to make a nice grid of things on the screen. And everyone was upset, and nobody really liked that, and people were doing horrible things to try to get things to line up in a grid. So they went out to make a grid implementation for iOS, but then they realized they can do something so much better than just a simple grid. They could make a way that you can collect things together and create two-dimensional views of anything in any layout that you want. And that is the UICollection View, whose default implementation is generally a grid, but it doesn't have to be. And you can do literally anything you want with it, and it's super amazing. But you use it the exact same way that you use a table view. And they were really awesome about that. So you really don't need to know anything extra if you understand fully the table view. Well, maybe a few little things, but not too much. You need these slides. I don't know what comes next.
Just like a UITableView, you have in your data source the 2 required methods. And Delegate, once again, there's no required methods. There's plenty of optional ones that you can see in the header. And then there's a delegate flow layout. This is a way of programmatically defining layout patterns, which I believe you can change.
Yeah, you can do literally any kind of layout that you want. It's some pretty cool stuff. But the default is normally some sort of grid style thing.
Yeah.
Going from, that's very row based.
So, I mean, along with this, we touched on UITableView and UICollection View. There's also UIPageView, and there's a few others, but they're all implemented basically exactly like this. You adhere to delegate protocol, you implement some methods, and you populate data in your views from your controllers. So that's the view controller relationship in MVC. Now I'm going to touch on actually bringing in models, and actually bringing data into your controller to put in your views. So iOS and Objective-C, so this is also a Mac framework, has this wonderful thing called CoreData. So CoreData. Basically, your models are NS managed objects, and when dealing with iOS, basically you're going to be dealing with this relationship here between your UI view controller and your NS managed object. So here's some things, some objects that you get with CoreData. We really don't deal with these too much, mainly your NS managed object and your NS managed object content, well, context, excuse me. But these have to deal with actually querying data, but we'll get to some of that later. So say you already have a project and you want to add CoreData to it. Well, you don't want to do that. It's easier to start a new CoreData project that has CoreData already set up and everything for you, because there's a lot of methods that need to be added and settings need to be changed to actually get CoreData working with your project. I spent a good 2 weeks trying to get CoreData to one of my projects at work because I didn't start with it, and I'm still not sure it works perfectly, but it's working for now. I'm sure I'll run into bugs down the road. But so what do you get with CoreData? So CoreData is fast. It's built into the operating system, and it's fast. That's all you need to know. It's actually based on SQLite 3, and it's actually faster than using SQLite 3. It does some crazy magic in the background. And it's very minimal overhead. As we see when we go look at the code later, once it's all set up, there's a matter of a few lines of code for getting data out of your databases. There's also things like automatic validation. So that comes with the model framework. I don't know if any of you guys have ever done Rails development. Like, there's a lot of verification that you can just do in your models. Less code, so minimal overhead. It's integrated with Cocoa. It's not directly like UIKit or anything, but very similar. It works very well with it. You can do some very sophisticated queries. You can layer queries on top of each other. There's like you query with these objects that you set up, and you set a bunch of attributes on them. We'll touch on that later. Automatic migrations. So when you change part of your database and you update your application, you don't even have to think about migrations. It just does it for you. And you can graphically build your schemes. So putting up together a relational database is very easy. And it's very scalable. So let's look at a new project that uses CoreData. So we've made a new project. We check the use CoreData, and we get some new things in our app delegate. These, the NS managed objects and persistent store coordinator, these are the things I talked about earlier. These are how you access your model and how you access your data. So, actually, I think these slides are in the wrong order because, actually no. You also have this Xcode data model. this is really bright. This is the graphical interface that you use to manage your database. So basically entities are like schemes in a database, and you have attributes, which are going to be tables, and then excuse me. The entire thing's the scheme. An entity is like a table, and then attributes are like columns in the table. So there's a few different types that you can have. We're going to use string, for example, in our code. You can have integers, floats, doubles, just Boolean values, NS dates actually. Put binary data in there so you can actually break down instances of objects and store them in the database if you wanted to. And I'm not quite sure what transformable is, but we still haven't touched on the actual model yet.
Real quick, transformable is a custom data.
Okay, so
if you implement NS managed object, I think, something like that. You can put your own data, your own object into CoreData, and you would use NS transformable something, I believe.
Yeah. There's documentation on it somewhere. I haven't seen it yet, but it's there. So, but creating your models actually is very easy in Xcode. If you actually go and you add a new file to your project, and you go to CoreData, and you make an NS managed object subclass, you get this nice thing where you can check what models you want to make or update. So if you change your database or something, or you added new attributes to an entity, you just do the same thing. You create a new file, and it doesn't overwrite the old file, but it just updates it with your new attributes. So you would just hit select and hit next, and it gives you your model objects. Not a lot in here. I've never really dealt too much with models, but if you put methods for your models in here. And notice we have dynamic. Basically that's saying it's going to be changed at runtime. Where are we? Alright, so these are the methods that were added to your app delegate. These are just more stuff working with CoreData to get these objects set up for you at runtime. Do you want to touch on a little bit on the app delegate now?
Sure. Okay, so this is the app delegate, right?
Yeah, it's not all in there. But
okay, so the app delegate is pretty much the main place where where iOS talks with your app. This is where your app starts up from, which is why all the CoreData files are, all the CoreData methods are in it. And you can access it as a singleton from anywhere in your program, because it's part of your app. You can just find it from anywhere, which is why the CoreData methods are placed here. If you need to have custom initialization when your app first loads up to, I don't know, check other files that you have somewhere in your app sandbox, then you would do it in your app delegate program, where the operating system asks your app to start everything up. Same thing for closing files when your app is being put into the background and being terminated. That's pretty much it.
Yeah. Alright, so, well, now that we have CoreData set up, we're going to show you how simple it is to actually use in code. So here's our brand new view controller. There's nothing in it yet, but we're going to add all the methods that we need to use CoreData. So, actually you don't technically need to add any methods. What I like to do is this here, where I create a method that I can easily call from anywhere that just takes care of this. So, what are we doing here? Well, first of all, we're getting an instance of our app delegate to access those CoreData objects and methods. So, we also have my entity, which is an instance of our model. This, as you can see by our method name, we're adding my new string to our database here. So, you take your model, you can pass this in from somewhere else if you're going to use it somewhere else. But basically, I'm making an instance of my model, and getting the app managed content. So this, you get your model with that, and then you set the attributes in your model, and then you can save it. So that's actually pretty simple. I don't think you'd actually pass your model around places, but you could pass in what you want to set into your model. But, I mean, you could pass your model around. But this is basically getting an instance of your model based on the database. And so fetching data is done similarly. You once again get the app delegate, and you use this NSFetchRequest. So you allocate it and you initialize it, and same thing, you get an instance of, you basically get all the information about the model and the database using this, and your managed object context. You set the entity that you're using in your fetch request, which is this here, and then you execute the request. So this is obviously a request that's just going to pull everything from it. So this is just error catching in case the query fails. But I touched on this in the next one. Actually doing queries is also very simple. So we also want to return, like this one is just getting an NS array of all the data in our database, so this will return an array of all our entities. But if you actually want to do more specific querying, you can do something like this, which is very similar to SQL querying. There's a little bit more you can do syntactically, and this is just one way of doing it. You can also, I don't have any of my notes. I won't let them but there's more ways to query other than just using this object. But like this here is just checking for something, any salary that is greater than 100. And it's just going to take those, put them into an NS array with your entities, and then spit it back out at you. You can also use NS sort descriptors when doing your querying. And what a sort descriptor is it allows you to sort arrays. So they're actually pretty cool. We don't touch on those at all. We should have. But, I mean, that's the very basics of CoreData. I hadn't done too much in querying, and I didn't have too much time to research into it, but there was plenty of good documentation on it. And once you get the basic idea of how CoreData works, like that's the hard part. Getting that set up and getting it working with your project is more difficult than I think it should be, but that's basically CoreData. So I'm going to jump ship here, and we're going to talk about the keyboard. So some important things to know about keyboard is these two methods and the size of it. So when you click on a text field, the keyboard automatically comes up. But if you've ever made an app, and you click on it and open up keyboard, you can never get rid of it. And you're like, why if I just not deselect this text box, why does my keyboard just not go away? Well, I don't know why, and I still think it should, but you have this method called first responder. So if you ever click out of your keyboard, you can call this and call this on all of your text boxes, and then the keyboard will go away. And here are the dimensions of the keyboard, because what you also have to do is if you have a view on the bottom of your application and you click on it, the keyboard will come up and cover up that view. So that your actual view doesn't move at all. But what you can do is on that view, call set origin, and actually move the coordinates up to bring the text field up into view so the keyboard doesn't cover it up. So, and now Steve is going to...
Isn't there a method to get the keyboard's current height? I'm pretty sure there is.
It's based on the orientation. The keyboard height is going to be consistent.
Well, the height of the keyboard changes in the... how much it shifts does change in the rotation. So
yeah, so we have, there's
different heights.
portrait and landscape, the different orientations. This is just for iPhone, but there is, the Apple documentation is there, and it is very good. Okay, and now Steve is going to take it away and talk about concurrency.
Ooh. Okay, so you get a really good concurrency library with the everything that you get with iOS development. I forgot what's called. It's not part of UIKit. I think it might be part of the Foundation framework. Let's go with that. Foundation framework gives you awesome concurrency stuff. What is it? NSOperationQueues. What the hell are those? Okay, so it's a queue or a line of different operations that you want to happen on some sort of thread. And you can have, these operations could be NS operations, which pretty much sum up to a call onto, or actually NS operations is a superclass name. But an operation could be anything, like a method call or whatever. But what you're going to use a lot, because Objective-C now has these, is NS block operations, because you like blocks, and blocks are great. So an operation in an operation queue waits until the operation queue says it's its turn to execute, and then it will execute either synchronously or asynchronously, depending on how you told the operation queue how that block should operate, should execute. And you use these queues mainly to ensure that variables are not modified at the same time, and that there are no concurrence issues with that. So how do you guarantee this? You make sure that every time you want to modify a variable, you always put it in a block that is placed in an operation queue. And it's always the same exact operation queue for that variable. Not too hard to manage yourself. It's actually quite easy to remember that. But you do have to remember that. Okay, so operation queues can be named so you can figure out which operation queue you're currently using. And there's a lot of stuff you can do with that name, but I don't really cover it right now. There are two really important class methods for NSOperationQueue that you're going to want to know. Main queue, which returns the queue associated with the main thread of the program, and the current queue, which is the queue associated with the current thread you're on, whether it's the main thread or some other thread that belongs to some other operation queue. Doesn't really matter which one, it's the one you're on. If you ever add something to the main queue, be wary that it won't get called until after you're done executing. So if that means that you have something synchronously on an operation queue, it will never get called and you'll be waiting forever. It's just not fun. So don't do it. Or maybe it's asynchronously, I forget which one. Either way, there's the setName variable down there, setName method down there. That's an instance method that you can use to set the name of the operation queue. So you can keep track of your operation queues. And so you can ask the current queue, which queue are you exactly? Also, it's good for debugging. Okay, so to create a new queue, it's very simple. You just call alloc and init, and you're done. And you have a nice new thread or whatever. It doesn't really matter how it's implemented in the back end. That's the magic of it. It's guaranteed. To add a block to a queue, you call add operation with block, and you pass in a block. The block takes no variables, takes no parameters, and returns nothing. So you can just use the caret and curly brackets. Just put your code in there. Nice and simple. You can wait for blocks to finish by using the add operations wait until finished method, and you pass in an NS array of NS operations. So in this case, I have an NS block operation, which is the one that I use most of the time because I really like blocks. And you initialize one with a class method call to NS block operation on the method block operation with block. And you pass in a block, and the block takes no variables and returns nothing. Returns void, so you can use the nice syntax. And then under that, you call on the queue that you want to add the block to, add operations, wait until finished. And you pass in the NS array, and you pass in the boolean. And if you want to wait until it's finished, then you press yes, and then your block gets called, and then your code continues. Otherwise, you pass in no, and your block gets called, and your code continues.
Question?
Okay. Yes.
In the previous slide, could you combine that into one statement?
Combine these two?
Yes.
Yes, I chose not to make it easier to read, but you could put this inside of this. It has to be an NS array that you're passing in, so I chose to use the object literal syntax. But it cannot be an NS operation block. a block operation, and it cannot be an Objective-C block. It has to be some array of NS operations. In this case, NS block operations. Cool. Grand Central Dispatch. What is that? Another new word. Well, NSOperationQueues are an Objective-C layer around this. This is a collection of C functions that take Objective-C blocks, and some of them take, and if you add an underscore F to all the calls, you can pass in a C function pointer instead. And they are the powerhouse for NS block operations and pretty much all concurrency in Objective-C. It's great. You don't have to think of threads at all, and you don't have to think of efficiency at all. You just have to think of your dispatch queues, which are just like NSOperationQueues, except for Grand Central Dispatch, and therefore Objective-C blocks and not block operation, and not NS operations. You would want to use Grand Central Dispatch if you wanted more control and more power than what NSOperationQueues can provide, because NSOperationQueues is fairly weak in comparison to the powerhouse of Grand Central Dispatch. Now, here are some basic things you might want to know about Grand Central Dispatch. First of all, how to make a dispatch queue. You call on the method dispatchQueueCreate, which returns a dispatch queue type, and you pass in a constant character array, which is the name of the dispatch queue, and the dispatch queue attribute enum value, which pretty much tells it I want to be a concurrent dispatch queue where my blocks are run asynchronously from each other, or I want to be a streamlined, I think it's streamlined, pretty much a synchronous queue where blocks are executed one at a time. And you might want to go for one or the other depending on which function you want to call on dispatch queue for Grand Central Dispatch, and I'll get to that later. You have the ability to fetch the main queue as well as other queues, but I only really call the main queue. Mention the main queue in this presentation to make it brief. With the dispatch get main queue function, which takes no parameters because it knows what you want and returns a dispatch queue. And that's akin to the NSOperationQueue main queue. Cool. Now you have these dispatch queues, but you actually want to use them because just having something is pretty useless. So you can either have a asynchronous or synchronous call to a block and place that on a dispatch queue. If you want an asynchronous call, which is a call that happens while your code executes, and you do not wait for it to finish, you call dispatch async. It returns nothing because it doesn't need to. And you pass it in the queue that you want to add it to, and the block that you want to add to the queue. The block takes nothing and returns nothing, just like NSOperationQueue. And the queue be whatever queue you want it to be. You can also wait for the block to complete with the synchronous call using dispatch sync, passing in the queue and the block, and that returns nothing. And the queue and the block are the same kinds of queue and block that you would use in the dispatch async. Nothing special there. Okay. You can do some really cool stuff like do a concurrent iteration over some block of code with Grand Central Dispatch, and this is why you would want to use concurrent dispatch queues. So you would do dispatch apply, which takes in the amount of iterations that you want, and the queue that you want to add the blocks to, and the block that you want to iterate over. Now this block, unlike the other blocks, takes in a parameter of type size t, which is pretty much a fancy way of saying unsigned integer, I'm pretty sure. And that is the iteration that this block is representing. So if it's the first iteration, it's 0. If it's the second, it's 1, 2, 3, etc., all the way up until the last iteration. Yep. And if you do this over the concurrent queue, all of these happen all at once. And that's really cool, because then something that could be really CPU intensive on one CPU, but you have more than one CPU, gets spread throughout all of them, and it happens a lot faster than it would have otherwise. Awesome. So that's Grand Central Dispatch. There's a lot more to offer, but I couldn't cover it all in this presentation because we wanted this presentation to be relatively brief so that we could get to other stuff as well. So, and the documentation for it is actually relatively easy. So long as you understand the basic concepts which I just explained, you should be able to understand more that you want to do. For example, you can just wait for arbitrary amounts of time before a block is executed, and if you just want to wait and not do anything, pass in an empty block. If you want to have semaphores, they're built right into Grand Central Dispatch, so you can use them right there. But I didn't put them in the presentation. There's great documentation on it, so go use that. And that's the end of our presentation. We didn't really cover much in this one compared to the other two, but we're here to answer your questions if you have any, and please ask questions because there's a lot more that we didn't cover that you might be interested in doing. So feel free to ask questions right now. Yes?
Is there like any way they could connect to MySQL databases without using a web server?
To a MySQL database?
Yeah.
Not Grand Central Dispatch. CoreData can be connected to any kind of database in the back end. CoreData is a front end for just arbitrary database access. So there is a way to say this is the database I want to use, but I don't know what that is exactly. I've used CoreData, but not that much.
So are you asking like to connect to a database that isn't on the device? You said something about a web server.
Yeah, I was going through an article which says like you need to write a web server which basically connects to the SQL and you can just in the server.
See, what you should do then is actually use like a RESTful API on the web server, and using networking frameworks in iOS actually do GET and POST requests to get like JSON data off the site, and then that's how you're going to get your information from a server. Doing like socket connections and stuff is usually a bad idea for if you're just getting data from a database, but so you would want to do that instead of actually connecting directly to a SQL database.
There's a library, AF networking.
I use that one. I personally recommend it.
Which is good.
Thanks for coming to the presentations. This presentation should be online, and the other two are already, so you can go watch them now. Awesome. Thanks.